All right, so in this example, we're going to look at how to solve a polynomial inequality of degree 3 where factor by grouping doesn't work. All right, so our first step is to notice that the inequality is not 0 on one side. So we need to start by taking the x and the negative 30 and moving those over. And that will give us x cubed minus 6x squared minus x plus 30 less than 0. And so now if we take a look at factor by grouping, in the first two terms, I can take out an x squared, and that'll leave me x minus 6. But in the second two terms, the best I can do is maybe take out a negative 1, and that's going to leave me x minus 30. And you can see that x minus 6 and x minus 30, those are not the same. And so factor by grouping is not going to be an option this time. So what we're going to need to do is back this train up and consider using a different technique. Okay, so what we're going to do is we're going to take the plus 30 and the lead coefficient of 1, and we're going to use something called the Rational Zero Theorem. And what the Rational Zero Theorem says, it says if you take all of the factors of the constant, which is 30, all of the factors of 30, which would be plus or minus 1, plus or minus 2, plus or minus 3. 4 doesn't go into 30 evenly, but 5 does. Plus or minus 5. 5 times 6 is 30. 3 times 10 is 30. 2 times 15 is 30. And 1 times 30 is 30. So you're going to take all the factors of the constant and divide those by all of the factors of the lead coefficient. Here the lead coefficient is 1, so the only factors of 1 would be plus and minus 1. And then if you divide all of those using all of your combinations, that would be 1 over 1, 2 over 1, 3 over 1, so on and so forth. But anything over 1 is itself. So here we have all of the possible rational zeros would be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 5, plus or minus 6, plus or minus 10, plus or minus 15, and plus or minus 30. Now that's a lot. 1, 2, 3, 4, 5, 6, 7, 8 times 2. That's 16 possible rational zeros, okay? That means that these are all of the possible rational solutions of this cubic polynomial here. And then what we're going to do is we're going to use synthetic division to try to find if any of these actually work. That means if any of these are actually solutions to this polynomial. So to do our synthetic division, we're going to start with the little box. And you can go in order if you want, or you can pick randomly. It doesn't matter. I think I'm just going to start with 2, be random here. And then we need all of the coefficients of the polynomial, which would be 1, negative 6, negative 1, and 30. 1, negative 6, negative 1, and 30. And we're going to do synthetic division, and we're going to hope for a 0 remainder. This is what we're shooting for, is a remainder of 0. Okay? Synthetic division, we're going to start by bringing the 1 down. 2 times 1 is 2. Negative 6 plus 2 is negative 4. Negative 4 times 2 is negative 8. That makes negative 9. Negative 9 times 2 is negative 18, and that is not going to be 0. So that means that positive 2 doesn't work, and so we can eliminate positive 2 from our choices. Okay, so then we're going to have to move on and pick a different number to try synthetic division with. I'm going to go with 3. And this is the process, okay? Looking for your possible solutions, you're just going to pick from all of these possible rational zeros and hope that one of them produces a 0 remainder. All right, so starting over again. 1, negative 6, negative 1, and 30. Okay, so the 1 comes down. 3 times 1 is 3. That's negative 3. That's negative 9, negative 10, negative 30. Oh, look at this. I only had to go 2 times, and I got a 0 remainder. Okay, now this is freaking sweet for 2 reasons. Okay, the first reason, that tells me now that positive 3 is a 0, which tells me that the original polynomial is going to have a factor of x minus 3, and the other factor is going to be a quadratic with 1, negative 3, and negative 10 as coefficients. So that means that the other factor is going to be x squared. See the 1 here, 1x squared minus 3x minus 10 is less than 0. So now this over here, this guy now factors like this. And so now that I know that x minus 3 is a factor, I know now that I can try to factor this trinomial and get my other 2 factors. And I know that there can be only 3 factors because we're dealing with a cubic. A degree 3 means 3 factors. Now, to try to factor the trinomial, we're going to read the signs. Minus makes the signs different, x and x. And are there numbers that multiply to make 10 that subtract and make 3? Yes, there are, 5 and 2. And I do want you to notice that as solutions, this would be negative 2 and positive 5, which are also in my list of possible rational zeros. So that is a nice tool that will give you all of the possible rational zeros, and that means that there cannot be any rational zeros outside of this list. So we had positive 3, negative 2, and positive 5. Those are my zeros down here. And so now that this is factored completely, I can now move on with solving the inequality, okay? So on the number line, I know that negative 2 is going to be a critical point. And since it's strictly less than 0, that's going to be an open circle. And then I know positive 3 is a critical point, and positive 5. And so the next step to solve this polynomial inequality, I need to figure out which of these 4 regions needs to be shaded. And we figure that out by using test points. So I need a number less than negative 2. Let's say negative 3. A number between negative 2 and 3, that could be 0. A number between 3 and 5, say 4. And a number bigger than 5, let's say 6. And now all of these test points are going to get plugged back into the inequality to see if we get a true or a false statement. So starting with negative 3, negative 3 minus 3, negative 3 plus 2, and negative 3 minus 5, we want to know, is that less than 0? Okay, so we have negative 6 times negative 1 times negative 8. Negative times a negative makes a positive. Positive times a negative makes a negative. So I know that this is going to be negative overall. And is a negative number less than 0? That is true. And so since we were testing the -3, that gave us a true statement, which means we're going to shade this region, which means that region is part of the solution set. Okay, and then knowing a little bit about math, these regions are probably going to alternate. So if the first region is true, then this is probably going to go false, true, false. Probably. I'm going to check it to make sure, but more than likely it's going to alternate. Okay, so then we're going to check 0. And to do that, we're going to go 0 minus 3, 0 plus 2, 0 minus 5. So again, do you see what I'm doing? I'm taking the 0 and plugging it in for each x in the factored form of the inequality. And then we're going to check to see if this is true or false. Okay, so that's going to be -3 times 2 times -5. Negative times a positive makes a negative, and then a negative times a negative makes a positive. So that's going to be a positive number. Is a positive number less than 0? No, a positive number is not less than 0, so that's false, which verifies what I said a second ago. And then we're going to check the other two test points, okay? So here we go. The next test point is 4. So we're going to say 4 minus 3, 4 plus 2, 4 minus 5. Is that less than 0? 4 minus 3, that's 1, times 6 times -1. Positive times a positive makes a positive. Positive times a negative makes a negative. Is a negative number less than 0? Yes, true dat. And so that means the 4 is true, which means that all of this in between 3 and 5 is part of the solution set. And one more number to check. Our next test point is 6. 6 minus 3, 6 plus 2, 6 minus 5. Is that less than 0? That's going to be 3 times 6 and 2 is 8. 6 minus 5 is 1. 3 times 8, that's 24. Is 24 less than 0? No, 24 is not less than 0. That is false, so that is not part of the solution set. Now then, we are all but done, okay? So now we're going to take the shaded regions and we're going to write that in interval notation. Okay, we're going to write the solution set using interval notation, and that's going to be everything from -infinity to -2. And the reason I'm going to infinity is notice that this shading shades forever to the left, going to -infinity, but it stops at 2. And since it's an open circle, I'm going to use a parenthesis. That means -2 is not included in the solution set. And then I'm going to use a union symbol because there's a gap. And then I have another interval, which is going to go from 3 to 5. And again, those both get parentheses because those are both open circles. And there is the solution in interval notation. And that is an example of how to solve a polynomial inequality of degree 3, where you have to use the rational zero theorem combined with synthetic division to get your polynomial factored. Man, I hope all that was helpful. If you have any questions or comments, feel free to put those in the comment section below, or you can text me. And thanks for watching.